Hi students, good morning to all. Today we are going to discuss probability exercise 8.4 addition theorem of probability. Addition theorem of probability. If A and B are two events, then we have a formula probability of A union B. Here A and B are two events. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Minus probability of A intersection B. Suppose three events. If A, B and C be the three events means we have a formula probability of A union B union C is equal to here A, B, C are the three events. Probability of A union B union C is equal to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of A intersection B intersection C. These two formulas we are using in addition theorem on probability, my dear students. So using these formulas we are going to solve some problems in listen, my dear students. Exercise 8.4. First question. If P of A is equal to 2 divided by 3, P of A value is 2 divided by 3 given. Probability of B value is 2 divided by 5. Probability of A union B is equal to 1 divided by 3. So we take given first. Given probability of A value is 2 divided by 3 and probability of B is equal to 2 divided by 5 and probability of A union B is equal to 1 divided by 3. Understand, my dear students? Now we know the formula. We want to find out probability of A intersection B. Probability of A intersection B we want to find out, my dear students. This is two event formula we want to apply here because A and B only two events are used. So we want to apply two events formula. A, B are the two events. So two events formula I want to apply. From this formula I want to find out probability of A intersection B. Already probability of A is given, probability of B also given, probability of A union B also given. Using these three we want to find out probability of A intersection B. So now we can use this first formula, my dear students. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Listen, my dear students. Now you send this probability of A intersection B to, let's say, it becomes plus probability of A intersection B is equal to now probability of A plus probability of B. Now you send this probability of A union B to right side, it becomes minus probability of A union B. Minus probability of A union B. Now probability of A intersection B you want to find out now. So probability of A value is 2 divided by 3 plus probability of B value is 2 divided by 5 minus probability of A union B value is 1 divided by 3. Understand, my dear students? Now we want to calculate these three fractions, 2 divided by 3 and 1 divided by 3, both having like denominators, my dear students. Both fractions having like denominator. So we can subtract the numerators directly. 2 minus 1. 2 minus 1 is nothing but 1. 2 minus 1 is nothing but 1 divided by 3, my dear students. Here plus 2 divided by 5. Now we want to add these two fractions, my dear students. Denominators are not same. So we want to do cross multiplication, my dear students. 1 pies are 5 plus 3 2s are 6 divided by 3 pies are 15. Now we get 5 plus 6, 11 divided by 15. So required answer is 11 divided by 15. That means probability of A intersection B value is 11 divided by 15. Okay, students. Next we will listen question number 2. A and B are two events such that probability of A value is 0.42, probability of B is 0.48 and probability of A intersection B is 0.16. Find P not A, second one, probability of not B, third one, probability of A or B. Understand, my dear students? Here not A means A complement, my dear students. Not means complement. Here not B means B complement, my dear students. This is probability of A complement. This is property of B complement. This is property of A or B. Here R means union, my dear students. Here R means union, not means complement. Understand, my dear students? Now we take the given first. Given. Here property of A value is 0.42. Then property of B value is 0.48. And property of A intersection B is equal to 0.16. So using this, you want to find out property of not A, property of not B, and property of A or B. First you take property of not A. Probability of not A. That means property of A complement. Property of A complement. That means property of A bar. Already we know that we know on formula, my dear students, property of A bar is nothing but 1 minus probability of A. Probability of A bar is equal to 1 minus probability of A. Already we know that 1 minus probability of A. Now 1 minus probability of A value is 0.42. 0.42. So this is 1.00, my dear students. This is 0.42. Subtracting these two, we get 10 minus 2, 8. This is 9 minus 4, 5.0, 0.58. 0.58. Understand, my dear students? Next is second one. Probability of B complement. Not B means B complement. B bar or B dash. Second one. Probability of not B. Not B means, my dear students, probability of B complement. Not B means probability of B complement. So probability of A bar means 1 minus probability of A. Probability of B bar means 1 minus probability of B. 1 minus probability of B. Now 1 minus probability of B value 0.48. 0.48. Subtracting these two, we get, my students, 1.00. So 1 we can write 1.00. This one is 0.48. Subtracting these two, we get 10 minus 8, 2, 9 minus 4, 5.0. 0.52. 0.52. You understand this, my dear students? Okay. Next, third one. Third, property of A or B. It's nothing but, my dear students, here R is coming. Therefore, we can take, instead of R, we can take union, my dear students. R means union. So, property of A union B, my dear students. Here R means union. Property of A union B. So, we know that property of A union B is equal to property of A. This is a formula for property of A union B, my dear students. Property of A union B is equal to property of A plus property of B minus property of A intersection B. Minus property of A intersection B. Here, property of A value is 0.42. Plus, property of B value is 0.48. 0.48. Minus property of A intersection B value is 0.16. So, both are positive value, my dear students. First, you add it now. 0.42 plus 0.48. So, adding these two, we get 0.42 plus 0.48. 10 remaining one, 9.0. 0.90, my dear students. 0.90. This you take as it is, minus 0.16. Now, subtracting these two, we get 0.90 minus 0.16, we get 10 minus 6, 4. 8 minus 1, 7. 0.74. This is the answer for our third question. Probability of A or B is nothing but probability of A union B. So we know the formula. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Understand, my dear students? The answer is 0.74. Okay. Next we are going to discuss question number 3. If A and B are two mutually exclusive event. Mutually exclusive event. You listen, my dear students. Mutually exclusive event means I am going to write one sample base here. Now sample base is equal to, I am taking first 5 natural numbers, my dear students. 1, 2, 3, 4, 5. Taking first 5 natural numbers. This is a sample base. So here n of s is equal to 5, my dear students. 1, 2, 3, 4, 5. N of S value is 5. So I am going to take one event, my dear students. Let A be the event of getting even number, my dear students. Event of getting even number means A is equal to event A has, how many even numbers are there in this sample space? 2 is a even number and 4 is a even number, 2, 4. Understand, my dear students? So now I am going to take one more event, my dear students. Let B be the event of getting all numbers. Event of getting all numbers, my dear students. Here B is equal to how many odd numbers are there in this sample space? 1 is a odd number, 3 is a odd number, 5 is a odd number. 1, 3, 5. Understand, my dear students? This is the event A has 2 even numbers, 2, 4. B even has 3 numbers, 3 odd numbers, 1, 3, 5. Now you see, my dear students, in A has 2 and 4, in B has 1, 3, 5. There is no common values. There is no common values for these two events. For these two events, there is no common elements. Understand, my dear students? There is no common elements. So, A intersection B is equal to 5. 5 means what? Nothing. No common values. So, A intersection, here intersection means what? A common. So, A intersection B is equal to 5. So, now I am going to find N of A intersection B is equal to, so A intersection B value 5 means N of A intersection B value is 0, my dear students. Nothing. No. Number of A intersection B is equal to nothing. 0. So, probability of A intersection B is equal to, this is an impossible event, my dear students. So, probability of A intersection B is equal to 0. Therefore, probability of A intersection B value is 0. So, you see, my dear students, here, event A has 2 values 2, 4. Event B has 3 values 1, 3, 5. There is no common values. In these two sets, there is no common values. So, that is why we can say A and B are mutually exclusive event. Here, A and B are mutually exclusive events. So, any common values there means, both are not mutually exclusive events. Both are not mutually exclusive events. Here, there is no common. In these two sets, there is no common. Therefore, these two sets, A and B, are called mutually exclusive events. Mutually exclusive event. Both are mutually exclusive event means probability of A intersection B value is 0. Mutually exclusive events means probability of A intersection B value is 0. Now you listen to this sum, my dear students. Now you know mutually exclusive event. Here A and B are mutually exclusive event because A intersection B is equal to 0. That means 5 nothing. Understand, my dear students? Now, given probability of A, not A, probability of not A is given. Probability of not A is equal to 0.45. So probability of not A is my dear students, probability of not A means A complement. Not A means probability of A complement is equal to 0.45. Understand, my dear students? Also given probability of A union B is equal to 0.65. Using these two given, we want to find out probability of B. We want to find out probability of B. Probability of B means, my dear students, for this, probability of A union B is nothing but probability of A plus probability of B minus probability of A intersection B, my dear students. Probability of A union B formula, probability of A plus probability of B minus probability of A intersection B. So, using that formula, we want to find out probability of B, my dear students. So, for this formula, we need probability of A. For this formula, we need a probability of A. So, using this probability of A bar, we want to find out probability of A. So, probability of A is equal to 1 minus probability of A bar. You know that probability of A is equal to 1 minus probability of A bar. Already you know that, my dear students. Probability of A bar is equal to 1 minus probability of A. Using this, we can find probability of A, my dear students. You send this minus probability of A to left side, it becomes plus probability of A, which is equal to 1. This probability of A bar goes to right side, becomes minus probability of A bar. So, probability of A is equal to 1 minus probability of A bar. Now, 1 minus probability of A bar value is 0.45. 0.45. So 1 minus 0.45 is nothing but 0.55. 1.00. This one is 0.45. Subtracting these two, we get 10 minus 5, 5, 9 minus 4, 5, 0.55. So probability of A value is 0.55, my dear students. So now also given probability of A union B equal to 0.65. Also given. Now we know that probability of A union B is equal to probability of A plus probability of B. Probability of A union formula, my dear students. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Probability of A intersection B. Here, probability of A intersection B is 0. Probability of A intersection B value is 0 because A and B are mutually exclusive events. A and B are mutually exclusive events in that question, given in question. Mutually, A and B are mutually exclusive event. Mutually exclusive event means no common. Understand, my dear students? Therefore, probability of A intersection B is 0. So, this probability of A intersection B value is 0, so you will leave it. Probability of A intersection B, you will leave it. So, probability of A union B you can take probability of A plus probability of B only. No need probability of A intersection B because the probability of A intersection B value is 0. So, probability of A union B is probability of A plus probability of B is equal to 0.65. Here, probability of A value is already got it, 0.55. 0.55 plus probability of B is equal to 0.65. Now, probability of B is equal to 0.65. This plus 0.55 goes to right side because minus 0.55. Now, subtracting these two, we get probability of B is equal to 0.10 is nothing but 0.1. 0.10 is nothing but 0.1. Understand, my dear students? Okay, next you listen question number 4, my dear students. The probability that at least one of A and B occur is 0.6. At least means R, my dear students. Probability of A or B. Probability of here at least means probability of A or B occur is 0.6, my dear students. R means you want to take union, my dear students. Given probability of A or B. At least means here R. At least one of A and B occurs. A or B means A union B is equal to 0.6, my dear students. Is equal to 0.6. Also given, if A and B occur simultaneously with probability 0.2, my dear students. A and B. Here and means intersection. We want to take intersection. A and B means A probability of A intersection B. Here at least is there means that is why we are taking union. Here and is there means we want to take intersection, my dear students. A and B occur simultaneously with probability 0.2. So probability of A and B is nothing but probability of A intersection B is equal to 0.2, my dear students. So I want to expand this or this. We get probability of A bar plus probability of B bar, my dear students. Now I am going to expand probability of A union B, my dear students. We know that probability of A union B is equal to 0.6. Now I am going to write formula for probability of A union B. We know that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B equal to 0.6. Equal to 0.6. Now we want to find out probability of A bar plus probability of B bar, my dear students. Here there is no probability of A bar plus probability of B bar, but probability of A is nothing but probability of A is nothing but 1 minus probability of A. We know that Probability of A bar is, probability of A is equal to 1 minus probability of A bar. Instead of probability of A, we can take 1 minus probability of A bar. Similarly, we can write probability of B is equal to 1 minus probability of B bar. 1 minus probability of B bar. So instead of this probability of B, we can take 1 minus probability of B bar minus probability of A intersection B value is 0.2, which is equal to 0.6. Understand, my dear students? Now, here 1 plus 1 is nothing but 2. This one is minus probability of A bar minus probability of this one minus probability of B bar is equal to 0.6. This minus 0.2 goes to right side, becomes plus 0.2. Plus 0.2. Now, 2 minus probability of A bar minus probability of B bar equal to 0.8, my dear students. Now, you send this 0.8 to left side. Already here 2 is there. 2 minus this plus 0.8 come to left side. It becomes minus 0.8, which is equal to this minus probability of A bar goes to right side, becomes plus probability of A bar. This minus probability of B bar goes to right side, it becomes plus probability of B bar. Now, 2 minus 0.8 is nothing but, my dear students, 1.2, which is equal to probability of A bar plus probability of B bar. Understand this, my dear students? They are asking probability of A bar plus probability of B bar. So, the value of probability of A bar plus probability of B bar is 1.2. Understand, my dear students? Okay, next you listen question number 5, my dear students. The probability of happening and event A is 0.5. Probability of happening of an event A is 0.5. It's nothing but, my dear students, probability of A event. Probability of event A is 0.5, my dear students. After that, and same thing, probability of B is 0.3, my dear students. Probability of event B is 0.3. These two things are given, my dear students. Using these two, I want to find out probability that neither A nor B, my dear students. Once again, listen. The probability of happening of an event A is 0.5. That means the probability of event A is 0.5, and that of a probability of B is 0.3. Probability of B is 0.3. If A and B are mutually exclusive event, already said, my dear students, probability of A and B are mutually exclusive event means probability of A intersection B is equal to 0. Already said this. A and B are mutually exclusive event means probability of A intersection B value is 0. Then find the probability that neither A nor B, my dear students. Probability of neither A nor B. That means, my dear students, neither A nor B means not in A and not in B. That means A complement and B complement, my dear students. That means probability of A bar and B bar. This we can say neither A nor B. Probability of A bar intersection B bar, not in A and not in B. Understand, my dear students? This we can write in De Morgan's law. We can write using De Morgan's law. Already we have studied in sets and functions, my dear students. Probability of A bar intersection B bar is equal to probability of A union B the whole bar. Already you know that. Probability of A union B the whole dash is equal to probability of A bar intersection B bar. Otherwise we can write whole bar. Understand, my dear students? Now probability of A intersection B the whole bar is equal to probability of A bar union B bar. Using De Morgan's theorem, we can write like that, my dear students. Probability of A bar intersection B bar means we can take like that. Property of A union B the whole bar. Property of A bar union B bar means we can write like that, my dear students. Property of A intersection B the whole bar. Now we know that property of A bar is equal to 1 minus property of A. Already we know that property of A bar is equal to 1 minus property of A. Here in this A bar place we have A union B. Here A bar means here you want to write A, my dear students. Here A union B the whole bar means here you want to write A union B. So property of A bar is nothing but 1 minus property of A. Similarly we can write this 1 minus property of A union B. 1 minus property of A union B. This we can write, my dear students. 1 minus, we know that property of A union B is equal to property of A plus property of B minus property of A intersection B. Understand, my dear students? We know that property of A union B is equal to property of A plus property of B minus property of A intersection B. Now 1 minus property of A value 0.5. Here, listen, my dear students. Here property of A intersection value is 0 because A and B are mutually exclusive event. A and B are mutually exclusive event. Therefore, property of A intersection value is 0. So here 0 will come. Property of A intersection value is 0. 0 will come. So no need to write that, my dear students. Property of A intersection B is no need because P of A intersection B value is 0 because of mutually exclusive events. So write the formula for A union B is property of A plus property of B is enough. No need property of A intersection B. Now, property of A value is 0.5 plus property of B value is 0.3. Now, 1 minus 0.5 plus 0.3, 0.8, my dear students. Now, final answer is 0.2. Property of neither A nor B is 0.2. Understand, my dear students? Okay, next we are going to discuss question number 6. 2 dice are rolled once. 2 dice are rolled once. Find the property of getting an even number. Find the property of getting an even number on the first die. On the first die. Or a total of face sum is 8. Total of face sum 8. Here 2 events are given in single question, my dear students. Two events. First event is an even number on the first die. It is a first event. The second event is total of face sum is 8. There are 2 events are given in this question, my dear students. So when we are getting 2 events in single question, in that time we want to use addition theorem, my dear students. Addition theorem for 2 events. Here 2 events are given. So addition theorem for 2 events is property of A union B is equal to property of A plus property of B plus property of A intersection, property of A plus property of B minus property of A intersection B, my dear students. For that we want to find out property of A, property of B and property of A intersection B. These 3 things we want to find out now, my dear students. So first you write sample base for 2 dice, my dear students. Now sample base S is equal to, sample base for 2 dice is, first die is 1, second die is 1, first die is 1, second die is 2. Like that you have to write, my dear students. 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. After that you have to write 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. This is sample base for 2 days, my dear students. Already you know that. That is why I am writing 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Next 4, 1, 4, 2, 4, 3, 4, 5, 4, 6, sorry, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Okay, next 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 6. After that 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. These are the sample place for 2 days, my dear students. Now here n of s is equal to 1, 2, 3, 4, 5, 6 rows are there, the 6 columns are there, 6 6 are 36. So n of s is equal to 36. Okay, listen, event, my dear students. First event E is getting an even number on the first day. Let A be the event of getting, let A be the event of getting an even number. Getting an even number on the first day. On the first day. Okay, listen, my dear students, what is our event? Getting an even number on the first day. On the first day, my dear students. So this is first day, this is second day value. This is first day outcome, this one is second day outcome. Okay, my dear students, what is our question? In first day, even number on the first day. Even number on the first day. So first values are first day outcome, second values are second day outcomes. You see first values, my dear students. If it is even means we can take. If it is even means we can take, otherwise we can leave that. Understand, my dear students? So in first row, you see all the first days outcomes are 1. In first row, all the first days outcomes are 1. So 1 is odd, but we need even numbers, my dear students. So first row, no, in first day, no even numbers. Okay, you come to next row, my dear students. Here 2, 2, 2, 2, 2, all are even number, my dear students, all are 2. Understand? So in second row, all the first days outcomes are even numbers. So you want to take this row fully, my dear students. After that, 3, 3, first day outcomes, 3, 3, 3, 3 are there. So 3 is odd number, you leave it. Next you come to fourth row, all are 4, my dear students. 4 is even, so you want to take this row fully, you want to take. After that, 5 is there. All the first day outcomes are 5. So 5 is a odd number, you leave it, my dear students. Come to third row. All the first day's outcomes are 6. 6 is an even number. So you take this row fully, my dear students. So 3 rows are selected. In these 3 rows, all the first day's outcomes are even. So here A is equal to 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Next, first day outcomes even number 4, 1, 4, 2, 4, 3, 4, 4, 5, and 4, 6. After 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. You don't consider second day's outcomes, my dear students. You want to consider first day's outcomes only. So if first day's outcomes is even means you want to take that, otherwise you leave it. Understand, my dear students? There are 18 possibilities are there, my dear students. Now n of A is equal to 18. Now probability of A is equal to n of A divided by n of S. That means n of P of A value 18 divided by n of S value 36. Understand, my dear students? Now first event is over. Next you come to the second event. Total of base sum is 8. Total of phase sum is 8. This is first phase value, this is second phase value. First day's value, this is second day's value. So, total of phase value must be 8. Understand, my dear? That only we want to take in second event. So, let B be the event of getting total of phase value or total of phase sum. Total of phase sum 8. Total of phase sum is 8. Now B is equal to, okay, you submit. How many possibilities are there? You take that. Here, first phase value is 1 and second phase value is 1. That also 1. 1 plus 1, 2 is coming. So because we need 8. We need 8. So here 2 is coming. Not possible, you leave it. Here 3, 4. Here 1 plus 4, 5. 1 plus 5, 6. 1 plus 6, 7. In first row, no possibilities. You come to next row. 2 plus 1, 3. 2 plus 2, 4. 2 plus 3, 5. 2 plus 4, 6. 2 plus 5, 7. 2 plus 6, 8. 8 is coming. The phase value, 8 is coming. So 2, 6 you want to take. Understand, my dear students? Total of phase sum is 8. 2 plus 6, 8, you know. So 2, 6. After that, here 3 plus 6 is 9. You leave it. Here 3 plus 5 is 8. You take 3, 5. 3 plus 5 is 8. After 4 plus 4 is 8. Understand? After that, 5 plus 3 is 8. 5, 3. After that, 6, 2 is 8. 6 plus 2, 8. Understand, my dear students? Only 5 possibilities, my dear students. Only we have 5 possibilities. So now, probability of, n of B is equal to 5. So probability of B is equal to n of B divided by n of S. N of B value 5, n of S value is 36. N of S value is 36. So 2 events are completed now, my dear students. After that, you want to check both the events are mutually exclusive or not. You want to check it now. So there is any common values are there in A event or B event. Now you want to check it now. Understand, my dear students? Here 2, 6 is there. Here 2, 6 is there. 2, 6 is common. Any one event is common means minimum one event is common means both events are not mutually exclusive event. So here A and common are there. Common values are there. Therefore, A and B are not mutually exclusive event. A and B are not mutually exclusive. A and B are not mutually exclusive events. Therefore, you want to find A intersection B also. Because common is there. Understand? Not mutually exclusive means common is there. Mutually exclusive event means no common. Understand, my dear students? Now you want to find out A intersection B also. Here 2, 6 is there. Here 2, 6 is there. So 2, 6 is common. After that, here 3, 5 is there. Here there is no 3, 5 because here first day. First, see, even name. Even number on the first day. So here first day in odd number is there. So 3, 5 not available in set A. Understand, my dear students? So now 4, 4 is there. Here also 4, 4 is there. So 4, 4 is common. 4, 4 is common. Here 5, 3 is there. Here there is no 5, 3. Here 6, 2 is there. Here 6, 2 is there. So 6, 2 is common. 6, 2 is common. So here n of A intersection B is equal to 3, my dear students. Common values. Number of common values is 3. So now probability of A intersection B is equal to n of A intersection B divided by n of S. Probability of B means n of b divided by n of s. Like that you want to write property of a intersection b means n of a intersection b divided by n of s minus minus. Here n of a intersection b value is 3, n of s value is 36. You understand, my dear students? Now we know property of a value and property of a b value and property of a intersection b value. Now we want to apply addition theorem, my dear students. Now we want to apply addition theorem. Addition theorem for two events. Property of A union B is equal to property of A plus property of B minus property of A intersection B. Property of A intersection B. Now the value of property of A is 18 divided by 36. 18 divided by 36. 18 divided by 36 plus property of B value is 5 divided by 36. 5 divided by 36 minus property of A intersection B value is 3 divided by 36. 3 divided by 36. Now all the denominators are same, my dear students. Denominator is 36. Numerator is 18 plus 5, 23. 23 minus 3. 18 plus 5, 23. 23 minus 3, 20, my dear students. Understand? Now you can simplify this in 4 tables, my dear students. 5 fours are 20. 9 fours are 36. So our answer is 5 divided by 9. Therefore, the required property is 5 divided by 9. Understand this, my dear students?